Hello children, welcome to Yamuna's physics classes. Today we have to discuss a topic of electronics or semiconductor devices known as diode as a rectifier, and that too a half wave rectifier. Now for this, let us think about an adapter. You know what is an adapter? What is an adapter? Adapter is nothing but what we use to charge our mobile phone. Okay, so this is an adapter. Think about, so this is a socket. We have a socket over here. You are placing the socket. Inside the socket you are placing the adapter, the other end to the phone connecting. So this is a battery within the mobile phone. Clear? Now the question is, if you don't have this part, what will happen? If you don't have this part, you are going directly, just directly you are giving this to the socket and then the phone and the end to the mobile. What will happen? It's very clear. You know, this is an AC or a fluctuating input with 230 volt and nearly 50 hertz frequency. So what will happen? This voltage, you know, every second it gets 50 times. 50 is the hertz. So in a second it fluctuates 50 times. So what will happen? So suppose in this clockwise direction, if the current is in clockwise direction, it is getting charged. What about the other half cycle? If the positive half cycle comes, maybe it is getting charged. The reverse, what will happen? Discharge. Don't think you don't have a transformer and you don't have a diode, nothing like that. Just you have the two wires, that's all, with the key switched off, on, keys on. So just imagine that condition. You have two wires here inside the socket, just given a wire here. At the time, what is happening is, this is too much voltage, that itself will damage the phone. Now if by some means you are suppose reducing the voltage also, you have some means to reduce the device, even then what's the problem? As it is a fluctuating AC, what will happen? During each half cycles, the current will be suppose flowing in clockwise. That time it is charging. Next half cycle it is going in the reverse manner, it is discharging. So what happens? Charging, discharging, charging, discharging. The procedure repeats and repeats and you are not able to charge the phone. So what's the remedy? What's the remedy? How to get a remedy for that? The answer is, you can on the switch at times when the current is flowing clockwise, off it anti-clockwise. So you have to do nearly 50 times per second. Is that possible? It's really a cumbersome job. It's not that easy. So what we are going to do is, number one, we want to reduce the voltage. We need not want 230 volt. So this is very, very familiar for you, a step down transformer. You have studied transformer in grade 10 or 9, right? So you know what is a transformer. And as the turns itself shows, here you have the number of turns is much more than the number of turns here. Primary winding, secondary winding. So this is for sure a step down transformer where the voltage is step down. Okay, so with this help of this step down transformer, you can reduce the AC input voltage. But now again you don't have the device diode. So what will happen? The same process. Once the voltage is stepped down, even then what happens? Charging, discharging, charging, discharging. This continuously go on. So again you won't be able to charge the battery. So now comes the answer. You cannot sit and open and close it. It's impossible, cumbersome job. So this is a very beautiful device known as a Pn Junction Diode. And it has a very cute symbol showing that is an arrowhead. You can see an arrow here. Beautiful arrowhead you can see here. This arrow simplifies or signifies. Simplify in the sense you need not remember which is positive, which is negative, all these things. Just the arrow itself says crystal clear, the current will be gone well inside the diode only in this direction. Current is allowed only to pass in this particular direction. That is the significance of the arrowhead here. So I can place the diode towards right, up, down, whatever it may be. But I place in this manner because I want a continuous current, only charging, no discharging. I need only charging, no discharging. So charging is happening in the clockwise direction. So I place the diode in such a manner that it conducts only while charging. Means from the figure it is clear, the current is in this manner. So I place the diode in the direction of the current so that it allows the load to get always current in one direction. Means it is allowing only current while it is charging, no discharging. But you know, AC is keeping on fluctuating, charging, discharging, charging, discharging. It is happening. But what diode is doing? Diode is actively allowing current only during positive half cycle. The other half cycle it remains silent. It doesn't do anything. Just like a traffic island waiting for the green signal. It is waiting for that green signal. Whenever the positive pulse reaches here, at the time it conducts. When the negative pulse reaches here, no, keep mum, nothing, no response. At that time it shows like red. Again when positive half cycle comes, it shows green, get in, get in, get in. Red, again block. So all these positive half cycle refers to red signal. All the negative cycles refers to red signals. So green, red, green, red. This refers to green. This refers to red. Similarly, it allows only current in one direction, known as unidirectional device. Clear? So this is the input waveform. This is the input what you are giving here. And this is the output waveform. So it is very clear, this is current versus time. So you know this is a full wave. One crest, one trough, a full wave. Of this, only when it is positive, it is conducting. When it is negative, the current is zero. You see the yellow line here? Yellow line parallel to time axis means y-axis is 0. So no current in this negative half cycle. Again when positive half cycle coming, allows. Again when negative coming, no current. So that's the only way. Positive go through, negative no current. Clear? So it is getting only working in a positive half cycle. So we will say this is a non-rectified input. This is a rectified output. When it is entering the diode, without the diode, if you don't have a diode, this is the figure. With the diode, this is the figure. Clear? Clear? So what is a rectifier? What is a rectifier? Answer is very simple. This get converted to this. Means what? This is AC. This is pulsating DC. Means what? One directional current. Direct current is a one direction, but it is pulsating. Pulsating in the sense it is fluctuating, but only in one direction. So that is known as a rectifier. Clear? So rectifier is a device which converts AC to pulsating DC. Now what's the principle? Pn junction diode conduct heavily, means the resistance will be very, very low when it is forward biased. What do you mean by forward biased? The positive of the diode connected to positive of the battery, negative to negative. That is known as forward biasing. Clear? And will not conduct in the reverse bias. If it is reverse, the reverse direction, it doesn't conduct. That's the principle used here. And what's the working? Working we have already mentioned. During positive half cycles, current flows through the load. Which is the load? The load is the one which you are taking the current from the circuit. Here, battery is a person who takes current from the circuit. So, whenever there is no current in the negative half cycle, during negative half cycles, you can see that no current is passing through the diode. The rectified output is only for the half of the input. So if you have a full wave here, output is only for half. That's why you call the term half wave rectifier. Now again come back to this adapter. we see the adapter like this. How can you see the adapter like this? The answer is the two wires, these two wires. This wire is taken well inside the mobile, and when it is coming out, the two are fused to one. And these two elements, the diode and the transformer, are packed up in this one. This inside this you have a transformer and a diode. The rest is the single wire. So exactly half-wave rectifier can be imagined as a adapter. Clear? And you have a remedy also. Now you can see during half cycles, each half cycle the diode remains silent. But you have another option, need not wait for the half cycle, that also you can make it into a pulsating DC by using one more diode along with this. So that will say full wave rectifier. And we will come to the next topic with full wave rectifier. So hope you can take a screenshot and learn very well. Thank you for listening. Thank you.